Let's continue through pressure. So this is the last of the different rules and equations we're going to be learning for pressure. After this, we'll be going through some pressure measurement devices before we finish up this chapter. So what is it? It's called Pascal's law. It simply says the pressure applied to confined fluid increases the pressure throughout by the same amount. Gibberish, right? It is. It's all about hydraulics. That's the big thing here. What it means is that if I have a small area and a small force, I can still have a significant pressure. Well, that pressure is going to be the same throughout the entire liquid. It doesn't matter that this is a small area. It doesn't matter that this is a small amount of fluid I'm pressing on. The pressure throughout the entire liquid is going to be the same, which means that that pressure over a large area will lead to a large force. So let's just do some numbers here so we can see this. So you get a point of what I'm doing here. I'm going to put 50 pounds right here, okay? 50 pounds over an area of, we'll make it really, really easy, an area of 1 inch squared. Well, I do that and I get a pressure that's equal to 50 psi. Now, if I have an area on the other side, let's say, I don't want to go too crazy. We'll say this is a diameter of 10 inches. That's somewhat crazy, but I'm trying to accentuate the numbers here a little bit. So that's a diameter of 10 inches. So area is going to be equal to pi d squared over 4. So it's going to be equal to 314 divided by 4. Calculator, come here. Okay, let's see what it is. And I just did multiply instead of divide. There you go. 78.5 inches. Okay. So that's my area. So force is going to be equal to pressure times area, which means I'm going to have a force of 3,925 pounds. So I put 50 pounds of pressure on one side. I put 3,925 pounds of pressure on the other side. That's how one of these little hydraulic jacks works. You're putting, honestly, a large amount of force on a tiny, tiny area which pumps fluid. That fluid then pushes it up. Because the area where you're pressing is smaller than the area where you're pushing, you put a lot more force lifting it up. And so a small force can lift a car. Pascal's law is fantastic. It's how hydraulics works. It's how you can solve some really interesting problems and you can do some amazing things. All of hydraulics is based on Pascal's law. This is why we can lift huge things using small, small forces or small, small pumps. And here's another way of writing it. Since pressure 1 and pressure 2 are the same, these ratios are also going to be the same. And this area right here is what's called the ideal mechanical advantage of a hydraulic lift. Ideal because in real life, there's going to be things like friction and other things that keep it from being perfect. It won't be the exact mechanical advantage, but that's the best case scenario. Okay, we'll stop here and then we'll try out another example next time. See y'all in a bit. Bye-bye.